How long is a day? Easy question, right? It's 24 hours. Except, well, actually, it depends on what kind of day you're talking about. And I don't mean the difference between, oh, Mondays, am I right? And oh, thank God it's Friday. Like, that's all human perception and the fact that we have soul crushing jobs. What I mean is, there's actually two different ways that you can measure a day. The first one, and the one that you're probably most familiar with, is what we call a solar day. So you look up in the sky, and at noon you see the sun at its highest point, and then you wait for the sun to come back up and back up to its highest point, and that's going to take you 24 hours. But if you did it at night, and instead of picking the sun, you picked some distant star, and you waited for that star to come back to that same position in the sky the following night, that's what we would call a sidereal day. And you would find that that's only 23 hours and 56 minutes. You'd be a whole 4 minutes short. So what's going on here? Well, as you know, the Earth spins. So you might think that if you start off by having the Earth point directly at the sun, or as we call that noon, and you let it complete one full 360-degree rotation, that you would end up pointing back at the sun again, that it would be noon again. But the Earth isn't just spinning around on its axis, it's also orbiting around the sun like this. And to see why that's such a big deal, let's look at a really extreme example. And let's assume that a year is only 4 days, in that it will take 4 days to revolve around the sun. Impossible, but it's an extreme example that highlights things. That means that the planet is traveling 90 degrees every day. So what happens is if the Earth rotates 360 degrees, but in that time, it has also moved a quarter of the way around the sun. And so you can see it's no longer pointed at the sun. In order for it to get back to noon, it is going to have to rotate an additional 90 degrees. So it's going to do a full 360 rotation plus 90 degrees. So that's 450 degrees that needs to turn in order to get back to this pointed back to the sun, back for it to be noon. But if instead we measured the day using the stars, we would find something much different. So the stars are so far away that they don't change position at all as we rotate around the sun. They're just so far away and we don't move that much around the sun by comparison. So in order to line back up with the stars, we have to rotate 360 degrees. And even though we've turned 1/4 of the way around the sun, we're still pointed in the same direction. That means it completes one full sidereal day in one 360-degree rotation. And that sidereal day would only be about 19 hours and 12 minutes. The sidereal day would be nearly 5 hours shorter than the solar day in this extreme example. The Earth is nowhere near this extreme. It takes us 365 days to complete one revolution around the sun. As we know, that's a year. So that just means that the Earth ends up having to turn an additional 0.986 degrees every day in order to get the sun back directly above head. So our solar day ends up being 24 hours. But if we just went by the stars, those distant stars, our day would be 23 hours and 56 minutes. It takes the Earth a full 4 minutes to rotate that extra 1 degree.